Hello, I'm Mr. Malden, and this is the Middle School Math Toolbox. Today, we are going over simple interest, all right? Maybe you've heard of the word interest before, maybe you haven't. Interest has to do with money, borrowing money, and having just to pay a little bit extra in order to be able to borrow that money. So let's start out today with a little bit of a story. Here's a story about a guy named Johnny. Here's Johnny. Hi, Johnny. How you doing? All right. And then there's also a girl that he met. Her name is, let's call her Felicia. All right. There's Felicia. And Johnny and Felicia, they just got married. All right. And they're starting their life off right. And they decide, you know what? They want to buy a house. All right. And this house is $200,000. All right, which in the area of the country that I live in is not too unreasonable for house costs. It's pretty normal. Other parts of the country, that's not very reasonable at all. But there we go. Well, they're going to buy a house, $200,000. Well, Johnny and Felicia, they don't have $200,000. They just paid for a wedding. They just paid for all sorts of other things. They've got their life that they're enjoying. They don't have $200,000. Maybe they have good jobs. Johnny's a teacher. Felicia's a doctor. You know, they're doing well for themselves. But right now, they don't have $200,000. Now, here's the reality. In life, there's very few individuals that have that much money to be able to just go and spend it on a house outright. So most of us in life, we have to go and borrow that money from somebody else. And so we might go to a bank. All right, here's a bank. We're going to call that the bank. The bank is where people store their money. All right, where savings accounts, also a place where people go and borrow money and things like that. But they decided they're going to go to the bank right there and ask for the $200,000 from the bank to buy the house. Well, they get to the bank and the bank says, "Yeah, that sounds like a good deal. You know, you've got good credit, you've got good jobs, you seem like good people from all factors that we can see. Yeah, we'd like to give you $200,000. Well, my question is, there's a relationship between the two of them. Now, Johnny and Felicia, they get the benefit of having the $200,000 right now to buy the house. But what benefit does the bank give them to loan it to them? Yeah, they're going to require them to pay back the $200,000 that they're borrowing. But the benefit that the bank is going to get is also a little bit of extra money. And we're going to call it $40,000, all right? It's different than that, but we're just going to go with that example for the moment. That extra money that the bank is going to get is called interest. That's the interest, all right? That's the little bit of extra money that the borrowers have to pay the lenders in order to be able to have the privilege of getting the money that they want right now. Ultimately, Johnny and Felicia are going to have to pay $200,000 back to the bank in order to borrow the $200,000 they need for the house. That's interest, all right? Seventh grade, we start kind of introducing you to this concept of interest. And then in eighth grade, you're gonna learn a different kind of interest. The interest that we learn in seventh grade is called simple interest, and so that's the nature of today's lesson. In eighth grade and beyond, you start learning about compound interest, which requires a complex algorithm and the use of a calculator and all that good stuff. But we start really basic in seventh grade with just a simple interest formula, because we really just want to kind of introduce you to this idea of how to calculate the little bit of extra money that you're going to have to pay if you borrow. Or in another scenario, maybe Johnny and Felicia decide, separately from buying a house, they also want to start a savings account. So we can call that their savings account down there. And they put $1,000 every month inside that savings account. And the bank says, okay, well, if you put that money in our bank, we're going to give you a little bit of extra money every month to be able to store that money here. And the bank's going to use that money to do all sorts of different things with it. All right, that's not really the nature of today's lesson. But the fact is, the bank gives them a little bit extra money, gives them interest in order to be able to help them, allow them to store the money at the bank. All right, and so Johnny and Felicia, after 1 month, they have $1,025 because the bank gave them $25 to be able to store the money. That extra money right there is also called interest. So interest has to do when somebody is borrowing money. Either people are borrowing money from a financial institution, or people are saving money, and in essence, the bank is borrowing the money, then, if you will, from the people. But ultimately, somebody's borrowing money, and so you're going to have to pay a little bit extra in order to be able to borrow that money. Okay. So we've got the formula there on the screen for simple interest, and this is it. I equals PRT. All right, or in other words, interest equals principal times rate times time. All right, so interest problems, simple interest problems, are going to have three numbers inside there, and you're going to use those three numbers to be able to find the missing piece. All right, most interest problems are asking for the interest, but a lot of them also might ask for the principal or the rate or the time. So we're going to talk about all of that. I've got a few problems to kind of walk through to be able to help us understand that. But before we get going with a word problem and an example, we kind of need to know what these different words mean. So let's start with that. We've got the word interest. All right, interest is the extra amount paid. We already need that. All right, so that's the I. Let me substitute this board out. I'll come back to that other board later if I need to. But we've got I equals PRT. All right, the I stands for interest. All right, that's the extra money that you have to pay. The P stands for principal. All right, principal is the original amount of the loan or the original amount of the savings. All right, so in Johnny and Felicia's situation, the principal is the original amount of money that they borrowed from the bank. Or in the separate scenario where they were saving money, it's the original amount of money that they put into the bank, the $1,000 down there. So those two are called the principal. All right. Usually a principal is really easy to find because you're going to see a dollar sign next to it. All right. But the principal is the original amount of the money that's either borrowed or saved. Then you've got a rate, all right? The rate is always given to you as a percent, like in that example right there. It's going to say the rate of 7% or the rate of 25% or so on and so forth, all right? The rate is always given to you as a percent, all right? That's the percent of money that of the principal that they're going to have to pay back per year, all right? So you're given the rate as a percent. But the tricky part is whenever you start going to calculate this and you insert the number for the R, you have to convert that percent to a decimal notation. All right. Doesn't mean that we're getting a different number. We're just representing this number a different way. All right. So instead of representing it as a percent, we've got to represent it as a decimal. And the way to make any number a decimal, so we're starting with 7%, we're going to take the decimal, we're going to move it 2 places to the left. And if you create an empty space right there, you need to put it in an empty number. All right. So 7% is 0.07, all right? The rate is always given to you as a percent, but you always have to convert it to a decimal in order to put it in for the R, all right? And then the final one is the time, all right? Time, T stands for time, so you're going to look for words like years or months or, in rare circumstances, days, all right? So you're going to find that word and you're going to use that number. Now, here's the thing about this, too. Just like rate is a little bit tricky, you have to put it in as a decimal. With time, you have to put it in as years because time, in regards to interest, is always calculated annually. All right, annually means yearly. So if the problem says 8 years, then you're going to put the 8 in for the T because it's years. But if it said months, all right, then you need to first convert that to years before you put it in for the T, all right? The T can only be put in as years. And so the quick and easy way to convert 8 months to years is just to divide it by 12 because there's 12 months in 1 year, all right? So 8 months is really 8/12 of a year, which is the same thing as 2/3, all right, if you simplified that fraction, all right? But that's how you do that, okay? So if it's given to you as years, you can put the number just like you see it inside for the time. If it's given to you as months, you need to convert it to years first. If it was given to you as days, All right, and that's rare circumstances. You don't see, usually when you're talking about interest, you're having to pay something back over a period of time. Usually it's not just a matter of days, it's more like a matter of months or years, all right? But if it did say days, you would just divide it by 365 because that's how many days are in a year, all right? So again, principal is the original amount of the loan, rate is the percent rate of the interest, all right? And you always want to convert that to a decimal before you put it in for R. And T stands for time, and you always want to put it in as years. So if you're given something other than years, you need to convert that to years before you put it in for the T. All right, let's go to a problem now, all right? We see this problem, $65,000 is put into a savings account, all right? So there you go. This is money being put in. It's savings, all right? And it earns 6% interest annually. The interest is not compounded. How much interest would the account earn after 7 years? All right, so there we go. I see a percent in the problem, okay, which maybe makes me think, well, maybe I need to use a percent proportion or a percent box or something like that. That's always the go-to that I tell my students. You know, if you see a percent, solve it as a percent proportion, all right? Use a percent box, unless you see the word interest in the problem, all right? If you see a percent inside the problem, you want to quickly scan the rest of that problem and see if you can find that word interest, all right? Interest is a big key word, all right? So you want to make sure that you try to scan the problem for that. In this case right here, you do see the word interest, all right? So you're not going to use a percent box. You're not going to use a percent proportion. You're going to use this formula, I equals PRT, all right? And when we know we're going to use a formula, I like to use this process. Formula, fill it, find it, all right? So we're going to start with the formula that we are using, all right, to be able to solve the problem. And then after we go through and we put the formula in here, I always go to the question first. And I'm looking at the question. So the key from this problem is I saw the word interest and I see the words not compounded, all right? You see those words not compounded? That means that we're dealing with simple interest and not compound interest, all right? So if I see the word interest and I see not compounded, I'm going to write down my formula right here, I equals PRT, because that is the formula for simple interest, all right? Then I'm going to look at the question and see what is the question specifically asking for. It says, how much interest would the account earn after 7 years? All right. Out of these 4 letters, the interest, the principal, the rate, or the time, the thing that we're looking for is the interest. So I go up here in the formula and I circle it just like that. Okay. So that when I go down to the fill it stage, I can do something very specific with that. Okay. So I circle the thing that we're looking for. Now then, we're going to go down to the fill it stage. Anything that's circled up here, you're going to leave just like you see it. So the I is going to stay the same. All right. But anything that's not circled, we're going to replace with a parentheses, just like this. There's a P, there's the R, there's the T, all right? So the principal, the rate, and the time. These are 3 different parentheses, place savers, if you will, for numbers that are going to be replacing the principal, the rate, and the time. Then I go to the problem, and I start looking for the various things that I'm looking for. The first parentheses is for the P, or the principal, all right, which is the original amount of the savings. In this case, it's $65,000, all right? So the principal here is $65,000. Then you've got the rate. When I'm looking for the rate, I'm looking for a percent inside the problem. There it is. I see a 6%, all right? But I'm not putting that 6% inside that parentheses right there. I've got to first convert that to a decimal in order to be able to put that inside for the rate, right? The rate is always put in as decimal notation. That's a common mistake. Just make sure you pay attention to this, that if you ever see the percent sign, right, that's your rate, but you don't want to put that number in there. You want to convert that number first to a decimal, which the easy way to do that is to move the decimal 2 places to the left. If you have an empty space, then you add a 0. Now, don't make a connection here that every time I've done this in the video, I've had to add a 0. Sometimes you have a percent like this that you're converting to a decimal and you move it 2 places, all right? And you don't have to add a 0 because there's not an empty space that you've created. You're only adding a 0 when you create an empty space. You're putting the 0 inside that empty space, all right? So we found our rate. That is 0.06. Finally, we've got to find our time, all right? And our time in this problem is the 7 years. We need to make sure and ensure, just check ourselves, does that say years? If it says years, we can put the number in just like we see it like in this problem. If it said months, we need to divide it by 12, all right? So then we just have to do the multiplication because this is saying principal times rate times time. So we just have 65,000 times 0.06, 0.06 times 7. And we get our answer of $27,300. All right? So the interest having to be paid is $27,000 and $27,300. All right? That's pretty easy, all right? But sometimes interest problems get a little bit complex, all right? And it comes with the question. All right, so this question asked how much interest would the account earn after the years. Let's pretend, which we found the interest, but let's pretend that the question says something a little bit different. Maybe the question says, what would the account have in total after the 7 years? Well, in total means that you have to find the interest, all right? But that's not all the money that's in that account. The interest is just the extra money that was gained, all right? So in total means you've got to add what you started with, which was $65,000, to this $27,300, all right? So in total, after 7 years, if we add the amount of money that we started with, we find out that in total, there's $92,300 in that account after 7 years, right? So if it says in total, you are going to have to find the interest, all right? But then you're also going to have to add that to the original principal in order to be able to find the total amount that's in that account, right? So now you know a little bit how to do this. Let's take this next one, all right? And I want you to try this on your own, all right? So what I want you to do is pause the video, go try this, see if you get it correct, all right? Pay attention to the question, pay attention to the words in there that are in the question, all right? Try to see if you get this done by yourself, and then come back to see if you get the correct answer. All right, it says John puts $4,000 into an account that earns 8% interest. The interest is not compounded. There's our phrase right there. It's not compound interest that we're dealing with. We're dealing with simple interest, all right, because there's only those two. How much money would he have in the account in total after 15 years? Well, I see a keyword right here, interest, all right? And then I see the words not compounded, all right? So I know I'm dealing with simple interest. So I've got to start with my simple interest formula, which is interest equals PRT. I equals principal times rate times time, all right? Now that I'm going to go back to the question, I'm going to find what are we looking for, all right? It says how much money would he have in the account in total after 15 years? So just like that last question, like when I talked about, in total means you've got the principal plus the interest equals the total amount that's in that bank account afterwards. So we are going to have to find the interest here in order to be able to find the total. So the thing that I need to find is the interest, and that's what I'm going to circle, right? So then I'm going to keep that letter the same, and then for the others, I'm writing parentheses here so that I have place savers for numbers. The first one, the P, is the principal. That's $4,000. That's the original amount of the savings, all right? The rate is 8%, but we need to convert that to a decimal before we put that in as our rate, and 8% as a decimal is 0.08, all right? And then the time, we need to look and see if it's given to us in years. It sure is. That 15 right there is 15 years, so we're going to put the 15 inside there. And then we're going to do the multiplication, all right? So we've got our parentheses all filled in. And we've got 4,000 times 0.08 times 15 equals 4,000 All right, so that's the interest. But before you start trying to go and click the answer, you want to go back to the question and just remember, what did the question ask for? The question asked for, what's the total amount in the account after the 15 years? Well, the total amount in the account includes the interest plus the principal in order to be able to find it. So the interest was 4,800 and the principal was 4,000. So we add to the interest the principal, and we've got $8,800. So in total, after the 15 years, there's $8,800 in that account. All right, let's do one more. And this one right here, we're going to have a question that's not it's not asking. It's about interest, but it's not asking for the interest. It's asking for something a little bit different. So we'll talk about how to be able to solve that. All right, so let's just go ahead and start by reading the question. Cecil wants to put $28,000 into an account for 7 years to have a total of $68,000 to use as a down payment for a house. Assuming the interest does not compound, there's our phrase again, we're dealing with simple interest, not compound interest. What rate of a return does Cecil need to meet his goal? Round to the nearest hundredth, all right? Well, because I see the word interest and I see does not compound, I know I'm dealing with simple interest, which means I need to start with the formula for the simple interest, which is I equals PRT, or interest equals principal times rate times time. All right, and then I need to go to the question, the sentence that is that ends in the question mark, and read it and ask, what am I asking? What is the question asking me for? It says, assuming the interest does not compound, what rate? All right, what we need to know is the rate of return that Cecil gets to meet his goal. So the letter that we're looking for is the R. All right, so when I carry it on down to the fillet stage, I'm going to replace all the other letters with a parentheses. So I is replaced with a parentheses. P is replaced with a parentheses. We're gonna keep our R, and we're gonna replace the T with the parentheses as well. So we have a place for 3 different numbers from the problem. All right, let's start with the easy numbers to be able to fill in. All right, the first easy number to fill in is the principal, which is the original amount of the savings. All right, that's the $28,000. That's the original amount before anything changed. All right, and then the time is 7 years. All right, so I saw it in years. I'm going to put it in there as years. All right, now then I have to think about the interest. And the quick thing to do would be just to take the other number right there and put it inside there. But you need to do a little bit of thinking. All right, it says right here that after the 7 years, he has in total $68,000. Remember, the total is going to be principal plus interest equals the total. So if we're told that the total is $68,000 and the principal is $28,000, all right, then the interest is the number that we add to $28,000 in order to get $68,000. And to be able to find that, all you have to do is subtract $68,000 minus $28,000, and you're going to get $40,000 as your interest, all right? So the interest is the extra money, all right? And in total means you're having to add the principal and the interest. So if you're given the total and you're given the principal, the way to find the interest is to subtract them, and you'll be able to find the interest just like that. All right? Now then, I see an equation with an expression over here that's simplified, but an expression over here that is not simplified. So we need to simplify this first. We need to do any multiplication that we can do. All right? Now then, the commutative property of multiplication tells us that you can multiply numbers in whichever order that you want to multiply them in order to fit your purposes. So in this case right here, if there's all multiplication, we can move these numbers around to multiply them in any order. So we're going to multiply 28,000 times 7. We're going to get 196,000 when we multiply those two numbers. And we don't need to forget the fact that we're going to have to multiply it by R in order to find the $40,000 that is the principal. Now we have a one-step equation, all right? I see 196,000 times R equals 40,000. and I want to get r by itself. So the way that I'm going to get r by itself is to undo the math that's going on with it. I've got to undo this multiply by 196,000, which the way to undo that is to do the inverse operation or the opposite, okay? And that is to divide. So if I'm multiplying r by 196,000, I have to divide by 196,000. That makes them cancel out, makes them go away, because 196,000 divided by 196,000 is 1, and 1 times r is just r, all right? But if I do something to one side of the equation, in order to stay balanced, I have to also do it to the other side of the equation as well. So ultimately, I have 40,000 divided by 196,000 is going to give me 0.20408, and it keeps on going, all right? Just like that. So it's, when I do the division here, I have a rate that is 0.20408, and it just keeps going on, all right, forever, right? Well, just like in other problems, it gives the rate that problems give it to us as percent, and we have to convert it to a decimal and work with it. When you're working with it, if you're finding the rate, it's going to be found as a decimal. You need to convert that back to a percent in order to represent it as your answer, all right? So the rate in this case would be, if I took that decimal and I went back to converting it to a percent, that means I'm going backwards. I'm moving it back to the right 2 places. I would have 20.4, and the problem said round to the nearest hundredth, so we're going to make that 0 go up to a 1 because that 8 is bigger than 5, all right? So my final rate here is 20.41%, okay? So again, once you know it's simple interest, go and figure out what are you asking for, or if they're asking for one of these 3 letters over here, circle it, and then rewrite all the variables as parentheses down here, but the one that's circled you're going to keep the same, all right? And then you're going to fill in the numbers that you need, all right? Whenever you're filling in the interest, if it doesn't say the interest is blah, 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 whatever it is, then that means you're going to have to do a little bit of work. You're going to have to take the total amount that you see, subtract the principal in order to find the extra money that you're going to get, the interest, all right? And then you're going to simplify expressions on both sides and then solve your one-step equation, all right? So interest problems, they're not necessarily hard. It's just a lot of things to remember, all right? It can be a little tricky at times, but the way to help it not be so tricky is pay attention to the question. What is the question asking for? All right, I hope you helped this. I hope this helped you some. If you made it to the end of the video and this was helpful for you, I encourage you to hit subscribe down below. I teach all my lessons. I record all my lessons and ultimately put them up. So if you're in 7th grade and you struggle with math, this could be a great place for you to come and get some help, all right? I hope you have a great day. If you have any comments, you can put the comments down below. Any questions, you can put that in the comments down below, and I'll answer those. Y'all have a great day. Okay, bye-bye.